Most developers learn one thing when building APIs: REST. And then they use REST for designing everything, whether it is chat systems, microservices, or real time updates. But large systems rarely work like that. Companies like Google, Netflix, and Meta use different communication styles for different problems. Things like gRPC, GraphQL, WebSockets, and event streaming. Today, we'll break down how these technologies actually work and when engineers choose each one. REST works because it is simple. It uses standard HTTP methods, and each resource has a URL. The server returns JSON. REST is stateless, which means every request contains everything that the server needs to process it. This makes it easy to cache responses, scale server horizontally, expose public APIs. That is why almost every public API on the internet uses REST. But REST has few structural problems. Problem number 1. Overfetching. Imagine a front end that only needs a user's name, but REST endpoint returns this. The client receives more data than it needs. Problem number 2. Underfetching. Sometimes the client needs multiple resources, for example users, posts, comments. With REST, this might require 3 separate requests, which increase latency. Problem number 3. Chatty microservices. REST works over HTTP 1.1, which means every request has significant overhead. In microservices where services talk constantly, this can become inefficient. This is where gRPC enters. gRPC was created by Google for high-performance service-to-service communication. Instead of JSON, it uses protocol buffers, which are binary, smaller, faster to serialize. Instead of defining APIs using URLs, you define them in a protofile. The protobuf compiler automatically generates client and server code, so your service communicates using strongly typed contracts. gRPC uses HTTP2, which allows multiplex requests, persistent connections, header compression. Instead of opening a new connection for each request, this dramatically reduces latency between services, thus making it fast. This makes it extremely powerful for microservices and internal APIs. But gRPC is not great for public APIs. Browsers don't natively support it well, which leads us to GraphQL. GraphQL was created at Facebook to solve REST's data fetching limitations. Instead of multiple endpoints, GraphQL exposes a single endpoint. The client sends a query describing exactly what it wants. The server responds with exactly that structure. This eliminates both overfetching and underfetching. Front-end teams love GraphQL because it gives them control over the data they request. This is extremely useful for mobile applications, complex dashboards, front-end heavy systems. But GraphQL introduces new challenges like caching complexity and potential N+1 query problems. Everything we discussed so far is request and response, but some systems need continuous communication, like chat systems. Calling REST APIs every second is inefficient. Instead, we use WebSockets. The connection starts as an HTTP request, but then it upgrades to a persistent TCP connection. After that, both sides can send message anytime. This allows real-time updates, low latency communication, bidirectional messaging. Instead of sending 1000 polling requests per minute, the server simply pushes update when something changes, which reduces the network overhead dramatically. There is another architecture pattern that many large-scale systems rely on: event-driven communication. Instead of services calling each other directly, they publish events. These events are sent to systems like Kafka or RabbitMQ. Other services subscribe and react asynchronously. This creates loosely coupled systems where services don't need to know who consumes the event, which makes scaling and evolving the system much easier. So how do you decide which approach to use? My advice is use REST for public APIs and simple services, gRPC for internal microservices communication where performance matters. Use GraphQL when front-end clients need flexible data queries. Use WebSockets when real-time updates are required. use event streaming for asynchronous workflow and large distributed systems. Knowing when to use REST, gRPC, GraphQL, WebSockets, or event streaming is what separates basic backend development from real system design.